So, energy recovery device. Now, what is happening? So, you have RO system, reverse osmosis, let us say this is RO membrane. Okay. Now, RO membrane is getting high pressure water, from where it is coming? It is coming from several filtration intake, seawater, then several filters like sand filter and anti-scaling agent, all these things will be there. Then it is going to RO membrane, then pressure is becoming lower, let us say this is 60 bar pressure is required about, and seawater concentration 35,000 ppm. Okay, and sand filter, other filter, there will be some pressure loss, let us say, as initially you ignore the pressure loss. Main pressure loss is coming in RO membrane. Okay, then after RO membrane also there will be certain amount of pressure. Okay, it is not becoming directly to atmospheric pressure. So, what is happening? You are getting your permeate and you are getting your reject. Okay, so reject is having higher pressure. So, what is happening? This pressure then it is getting wasted. Pressure means energy. What is having pressure? So, they make certain arrangement, energy recovery device. Okay, then that energy will be supplied to here also. Okay, so here will be pump. Okay, so this high pressure reject will be giving certain amount to energy recovery device, and this energy will be given to this pressure to the system. So, certain amount of energy you are recovering using that mechanism. In brackish water, where pressure requirement is very low, it is not 60 bar, it will be much lower than 60 bar. So, in that case this energy exchange system not required. Okay, but if you are using for seawater desalination, so in that case you are giving huge amount of energy to generate the high pressure. So, you want to recover certain amount of energy, in that case you are using energy recovery device or ERD. While most seawater RO plants incorporate ERDs to reduce energy consumption, brackish water RO plant commonly do not employ ERD due to economic consideration. So, you can use also, you can, but that will be increasing cost, actually increasing maintenance other cost, because this energy recovery device, I was reading certain document and they are saying like energy recovering device is there, but still those systems are not efficient. Okay, again you are using for brackish water where pressure requirement already low, and so it will be, you are putting extra money but you are not getting that much of benefit. That is why normally people will be avoiding. The energy recovery device retrieve hydraulic energy from the high pressure reject stream and channels it into the feed stream. Okay, so this is from reject, how much pressure is there, that one you are recovering. This means that, for instance, the high pressure pumps would only need to supply 16.75 meter cube per hour, and this some data you can remember. Okay. Now, desalination, I said like RO system is there, but there are several other desalination systems. Okay, what are the several most widely used systems are there? Here one membrane system, already we explained. Membrane is one will be RO based system and will be ED. ED means, you see left side full form is written there, electrodialysis system also there. We are not discussing in details of all these things. We will be focusing on RO and some thermal systems. Okay, but you should know what are the different mechanism available. Okay, one is membrane system, another is thermal system. Thermal system is you increase temperature, evaporate and you cool down or reduce pressure, and again you can create concentration or evaporation, that way you can get. Okay, so from thermal you can get MEE. MEE means like multi effect evaporator will be there, then multi effect parallel feed, forward feed, vertical stack. So, many types are there. So, many types, again TBC, MBC. So, many different types are there. Okay, here MSF, SE, freezing, solar steel is there, HDH is there. Yeah, for your course we are not discussing everything, but you should know that there are many other types. Okay, but we should discuss only membrane and only evaporative type, mechanical type. Two types I will discuss. Okay, so whenever you are giving energy, so there will be thermal energy you are giving. Some cases mechanical energy you are giving. Mechanical energy giving means actually basically one pump is working. in mechanical energy system, then you are getting RO, reverse osmosis based system, and you are purifying water. In thermal energy system like distillation, you have seen already, you increase temperature, you boil water, you cool down, you get water, right. In some cases you are giving electricity directly. So, electrodialysis system is there. So, you can get directly electricity, directly water from electrodialysis systems. And if you go further, thermal energy system, so they will have different options also. Okay. So, desalinating water with multi-stage flash evaporator. So, this is not RO based system, this is just evaporation and condensation system. Okay. So, how it is working, first you have to understand. So, you are taking seawater, okay, seawater is taken and it is going through this one, and this is cold seawater actually. Okay, it is cold seawater. Cold seawater taking and it is going through like this. Then there will be brine system. So, higher temperature, this temperature is high. Okay. So, you are increasing temperature, then this high temperature fluid, it is coming through this and your pressure is 400 millibar. Okay. Now, because 400 millibar and here this pipe is carrying low temperature fluid. Okay. So, first chamber it is coming, this you see this chamber. Okay. Some fluid coming to first chamber after heating. Now, here pressure is lower, 400 millibar, and upper part some cooling pipe also there. When it will be giving lots of vapor, so vapor will be getting cooled down, it will be collected here. Okay. So, here vapor is cooled, condensation. Okay, condensation happening. So, you got certain filtered water. Now, this water will go further this chamber, their pressure will be further lower, less than 400 millibar, but still it will be giving up certain amount of vapor, because this pipe temperature is lower, this seawater pipe, low temperature pipe, and pressure will be lower. Because of lower pressure, again certain amount of vapor you are getting from water surface. If you are reducing pressure, you are getting more vapor. So, vapor when it is going top, cold pipe is there, cold pipe will be reducing temperature, you are getting concentration, concentrated water, okay, or condensed water. Then again this water is going to this, again further pressure down, finally it is going to 80 millibar. So, 400 to 80 millibar, gradually you reduce pressure, and every step you are reducing, pressure is going down and your cold pipe is there. Because of low pressure, you are getting more vapor, vapor is condensed by the cold pipe. Okay. So, that way the condensed water you collect, that is your potable water. Okay. So, indirectly you are evaporating and cooling, like if you boil water, you are getting directly steam and a cooling, that, but here instead of doing that boiling option, you are reducing pressure using seabed cold temperature. Seabed temperature will be around 4 degrees. So, that temperature you are using and you are making flash evaporation system. Okay. So, this is called multi-stage, means first stage 400 millibar, second stage maybe 300 millibar, 200, 100. So, you see right side text, some facility may comprise up to 30 stages. Okay. So, bigger unit will have lots of stages, so you will get more water. Okay. Efficiency will be increasing. Plants account approximately 26% of global desalination water production, but newer systems they prefer RO based system, because RO based system is low energy consumption and easy to handle, very simpler system. So, this is having more bulkier, heavier system. Okay. So, here are some more things are there. So, last stage you can see brine is going to water again, because it is ocean anyway. So, brine will be going to ocean. So, sometimes brine can be used for some other commercial purpose also, but normally it will be going to ocean. Small amount of brine if it is there, then just spread in the ocean, done. And here seawater intake ejector is there. Okay. So, what is that purpose? So, what happens, seawater you take from surface, any seawater, then ejector. What is ejector? Ejector is like this. Ejector means one nozzle is here, okay, and high pressure fluid water is coming, seawater, okay, seawater coming through this pipe and like this. So, what is happening, this ejector is getting seawater and there is the system. I will draw like this, okay, then this system is there, this system is there, okay. So, what happens when fluid is flowing through pipe and if suddenly reduce pipe size because of Bernoulli's law, pressure will be reduced. How? P by rho g plus V square by 2g equals constant, right? You know the Bernoulli's equation. So, let us say point 1, point 2 you create. So, point 1 pressure and velocity you got. Point 2 you reduce diameter. When reduce diameter, fluid velocity increase actually, because same flow rate you have to maintain, it is water incompressible fluid, same velocity you are same flow rate you are maintaining and velocity will be flow rate divided by area, okay. Now, point 2 area is changed, okay, I will explain like this, area A2, area A1, okay. So, A1 velocity V1 equals Q by A1 and A2 velocity V2 gives Q by A2, okay. You see this area reduced. So, area reduced means velocity 2 is increased. So, when velocity 2 increase, you go to again Bernoulli's equation, velocity increase, so pressure must be reduced. This is energy equation. So, you are not destroying energy or not creating. So, when velocity reduced, velocity increase, pressure must be reducing. So, at point 2 your velocity got down. When velocity got down, your this pressure become lower, okay. So, this is low pressure, okay. So, system is like this, I have pipe, then size reduced, then design is like this, okay. There will be intake pipe. So, 1, 2, point 2 your pressure reduced. So, point 2 is connected to this one, 3, okay. From 3 fluid will be sucked or it will create low pressure, okay. So, whatever low pressure you are creating because of this ejector effect, okay. You have one pump, you are pumping high pressure fluid passing through a nozzle, nozzle creating low pressure, that low pressure is connected to your stages, okay. So, you are getting seawater cold temperature, you are getting low pressure from seawater again, even pump will be running and another temperature source must be there left side, the brine temperature source. So, that temperature, how the temperature will be generated, you have loss of waste heat, so you can generate temperature and you can increase temperature, okay. Where the other applications of in offshore area where you can generate desalinated water, Lakshadweep area, NIOT, National Institute of Ocean Technology in Chennai, they design low temperature thermal desalination system using ocean thermal energy. How? You have sea surface, you have sea bed. Sea bed temperature already you know about 4 degree and sea surface temperature in Chennai nearby it will be around 30 degree, 28-30 degree, right. So, you have temperature difference 4 degree and 30 degree. Using that one, actually they are trying to they are running their low temperature desalination system. So, at low temperature and they are getting low pressure, because of that they are generating lots of water for Lakshadweep people. So, water evaporated low temperature under reduced pressure, okay. In previous slide you have seen. So, vacuum pump creates a low pressure, low temperature environment facilitating water evaporation despite a modest temperature difference of 8 degree. So, about 8 degree temperature also it can create certain water, okay. So, cold water from 600 meter depth, NIOT collecting cold water from 600 meter water depth. So, the water depth is not 4 degree, rather nearby 4 degree, okay, maybe 8 degree. So, they installed this one at Kavaratti island, you can see for 1 lakh 0.1 million liter per day water they are producing, and deep sea water temperature rising 7 to 15 degrees. So, within that temperature range they are collecting water, and surface the temperatures at surface different, seabed temperature difference. Using the temperature difference they are running this flash evaporation system. Okay. Ocean thermal energy conversion, again this is NIOT working, and sometime IIT Madras also will be involved in this case. So, many professors are involved. Ocean thermal energy, how you harness energy from there. So, let us say it is open cycle. What will do? You take this warm water, surface water 25 to 30 degrees centigrade temperature, and it will go to low pressure evaporation. Water vapor will be going, it will be running at going through turbine. Turbine will be giving electricity. That electricity you use for running pump for your desalination system. Okay. Then run pump for desalination system. Okay. Then turbine, again you condense, again you can put that water into the sea. And how to condense? You are having seabed temperature around 3 to 7 degree, 4 to 7 degree actually. So, this cycle will be running continuously, and you are getting certain amount of electricity. The thermal performance is very low, but still people are trying to develop this technology, because the cost involved, only initial cost is involved. After that, energy free, because you put in the ocean and you are not giving any fuel or any other thing. Okay, only the installation cost is required, other thing there is no money required, right. So, that is why still lots of research going on. NIOT is working, and US and many other countries also working, Japan. And yeah, so renewable energy harness from temperature difference. Three types of system may be there: closed system, open system, hybrid system. This is open system. So, water taking from ocean, again throwing in the ocean. So, same water is not circulating, that's why it is open. Okay. And another system is closed cycle, I will explain later. Closed system will be using ammonia, then how it will work I will explain. So, open cycle uses warm surface water to produce electricity, leaving vapor behind fresh water after condensation. Some variation of employs vapor lift pump techniques for power generation. Hybrid also there. So, open and closed system both coupled together, they will make hybrid system. So, what is closed cycle? Closed cycle, actually you can remember your thermal power plant, okay, Rankine cycle. How? So, evaporator, you can assume that one for your boiler, okay, you can remember it is boiler, and boiler you are getting high temperature, high pressure steam, it is going to a turbine. Okay, I can draw like this, every time I am drawing same way I will draw, right. Turbine, then you have one condenser, then pump, okay. You can remember the same cycle actually. Left side, this is they are saying closed cycle for ocean thermal energy conversion, but same actually, this is Rankine cycle. Okay, so this thing also you can draw in TS diagram, right. It will be like this, pump will be working, then it will be like this. And working fluid, normally it will be ammonia. Okay, other options are there, CFC, HFC, hydrocarbons, so many other options also there, but ammonia normally used by the OTEC scientists or OTEC research units. Another desalination work, we are working with Department of Energy USA. So, our system was a wave energy based desalination. So, how did you arrive the idea? We have one flat surge converter, wave energy converter. So, wave energy converter, when wave will be passing over this one, it will be moving forward backward, motion will be there. When forward backward motion is there, actually you can create one reciprocating pump here. Okay. So, reciprocating pump will take water from sea water, then this water you send to your RO module. Okay. RO module, when you are sending, you are getting pure water. So, that was our concept, but I am showing direct picture. It is not the work is not like so simple. We will have like sand filter, and many other filters. Other filters, then we'll have one accumulator. Why one accumulator will be required? Because reciprocating pump giving pressure in pulse form. Okay, like when surge converter, this will have one. Okay, surge converter moving forward backward because of wave will be moving over this flat plate. So when wave is moving over this one, it will be moving like this. When now you have one rod connect as a piston cylinder, so you are pumping, but fluid will be flowing like this, pulsed, right? When it is moving, fluid flowing, this side no flowing, so flowing, flowing, flowing like this. So that way your RO system will not work. So what you do, you put one accumulator. Accumulator, what will it do? Accumulator actually it will be absorbing all the pulsed water, and it will be giving uniform water to RO module. How accumulators work? Accumulator is like this. Okay, I have input, output, and this is actually a nitrogen filled dome. Okay, and when water is coming, it will be entering, and nitrogen will be getting compressed, and we will have one valve. Actually, it will not open normally. When 60 bar pressure will be coming, this valve will be opening. So initially you pump, continuously pump, nitrogen will be compressed, compressed, compressed. So all the pulses will be absorbed. When 60 bar will be reached, this valve will be opening. So this valve, when it is opening, our output pressure will be almost smooth, about 60 bar constant. But input pressure will be like this, output pressure will be like this. Okay, so this concept actually we presented. We did some research work for Department of Energy. So we are working further to develop this technology. Directly wave energy can be converted in, can be used for your desalination purpose, and that can be used for your local offshore community or coastal communities. So thank you very much for listening to the lecture. Next day we will come with new topics. Thank you.